In this video, we are going to talk about factoring. So if you have not done this warm-up yet, please pause the video and try this warm-up now. So you want to find two numbers, for example in A, that multiply to 16, and then those same two numbers add to 10. So take a moment, do this warm-up if you haven't already. Alright, now that you've completed the warm-up, let's go over it. In A, two numbers that multiply to 16 but add to 10. Well, if I think about numbers that multiply to 16, I have 1 and 16, 2 and 8, 4 and 4. So the two numbers that would multiply to 16 and add to 10 would be 2 and 8. Let's do the same thing for B. So I'm looking for two numbers that multiply to 35 but add to 12. So that would be 5 and 7. Now C and D get a little bit trickier. C and D, I want to find two numbers that multiply to negative 27 but add to 6. So I'm going to write down all the things that multiply to 27 and then think about, well, if it's negative 27, that means one of them would need to be negative. So if I do negative 3 and positive 9, that would multiply to negative 27 but add to positive 6. All right, in D with 15, we have 1 and 15 and 3 and 5. So again, with 15, negative 15, one of the numbers would need to be negative. So if I make the 5 negative, that means 3 and negative 5 would multiply to negative 15, but add to negative 2. So this is going to help us today with our factoring. Today in factoring, we are going to go over how to factor a greatest common factor, a difference of squares. We are actually not going to do this second objective. We're going to save this for later. But we are all going to factor trinomials when A is 1. So first let's talk about what is a greatest common factor. A greatest common factor is the greatest or biggest number that is a factor, or sometimes we call it a divisor, of both original numbers. So let's take this into a factoring sense. I'm going to factor using the distributive property, or GCF. So basically I'm going to undistribute. So if I'm looking at 4 and 12, I want to figure out what is the greatest common factor. So if I think about 4, what goes into 4 is 1 and 4 and 2 and 2. What goes into 12 is 1 and 12, 2 and 6, 3 and 4. So by looking at this list, I can see that 4 is the biggest factor for 4 and 12. So to factor by GCF, I'm going to divide both of these by 4. I'm going to put the 4 on the outside, and then I'm going to divide. So 4x divided by 4 would give me x. 12 divided by 4 would give me 3. So basically, I'm undistributing the greatest common factor. Let's look at number 2. In number 2, I say I have x squared and negative 3x. So I can see that these both have an x in common. I know there's technically a 1 in front of here, so between 1 and 3, the only GCF is 1. So I'm really just going to take out just an x. So when you do x squared divided by x the first, you're left with 1x. And when I do 3x divided by x, I'm left with 3. So again, if I were to redistribute this, I would do x times x is x squared. And x times negative 3 would be negative 3x, which would get me back to what I started with. So we're basically undistributing. All right, in number 3, I have 3 and 15. So 3 is 1 and 3. 15 is 1 and 15, and 3 and 5. So I can see that 3 is my greatest common factor. So I'm going to divide by 3, put the divisor in front. 3y divided by 3 will leave me with just y. 15 divided by 3 would leave me with 5. So 3 times y plus 5. In this last one, similar to the one above it, I have x squared and negative 5x. So they both have x in common. So I'm going to take out an x, and I'll be left with x minus 5. Because x squared divided by x to the first will leave me with x. 5x divided by x will leave me with just negative 5. All right, let's try another type of factoring. So now we're talking about factoring a standard form of a quadratic. So we have ax squared plus bx plus c, but we're going to focus on when my a is 1, meaning when there's nothing in front of my x squared. So when my a is 1, we are going to find two numbers that multiply to my c value and add to my b value. So what does that mean? If I look, I have a, b, and c. So my c value is my 3. So I'm looking for two numbers that multiply to 3, but then add to my b, so add to 4. So, and then when I'm going to write this, once I figure out those two numbers, then I'm going to write the factors into two parentheses. So basically I'm unfoiling this. So if I think about x squared, well, x squared would be x times x, and that's the only way I could really get x squared. So when I write my factors, I'm going to put x and x in the beginning, because if I were to FOIL this out, I would do x times x is x squared. So I'm going to erase that for right now. So then the two numbers that are going to go here and here are going to be the two numbers that I decide multiply to 3 but add to 4. So two numbers, so things that multiply to 3. So this one's a little bit easier because there's only two factors, 1 and 3. But we can always make a t-chart to figure out our multiplication factors. So 1 and 3 will multiply to 3, and 1 and 3 will add to 4. So positive 1 and positive 3 would be my factors. Now, this is my final answer. So let's say I were to check. We can check that it's right by re-multiplying it back together. So I would do x times x is x squared. X times 3 is 3x. 1 times x is 1x. And 1 times 3 is 3. The two middle terms, the 3x and the 1x, would add to 4x. And then I'm back to where I started. So I know that x plus 1 and x plus 3 is my final answer. All right, let's give this a try with a couple other problems. So our directions say factor completely. So again, I want to find two numbers that multiply to 12 but add to 8. So it's going to be x and x. So I'm going to find two numbers that multiply to 12 but add to 8. So I'm going to write down things that multiply to 12. So 1 and 12, 2 and 6, 3 and 4. So when I look at this list, I see that 2 and 6 multiply to 12, but they'll also add to 8. So positive 2 and positive 6 are going to be my factors. So my factors will be x plus 2 and x plus 6. All right, number 2 is a little bit trickier. So I want to find things that multiply to negative 11. So multiply to negative 11, but add to negative 10. So again, x, x. So things that multiply to negative 11. Well, 1 and negative 11 or negative 1 and 11 is really about it because 11 is a prime number. So if I want to have negative 11, I want them to add to negative 10, that means it had to be 1 and negative 11. So positive 1, negative 11 would be my factors. All right, 3 looks a little different, but we're actually going to treat it the same. It's actually missing the middle term. So I'm going to rewrite this as x squared plus 0x minus 25, because basically it was just missing that middle term. So now I'm looking for two numbers that add to 0, but multiply to negative 25. So if I think about negative 25, negative 1 and 25, 1 and negative 25, or negative 5 and 5. So it's those negative 5 and 5 that are actually going to give me that adds to 0 and multiplies to 25. Because negative 5 plus 5 would add to 0, which is what I'm looking for it to do, but multiply to 25. So it would be negative 5 plus 5. Four is very similar. Again, we're missing that middle term, so it's really x squared plus 0x minus 36. So I'm looking for two numbers that multiply to negative 36 but add to 0. So 36 is a lot of factors, so I'm just going to write down all the positive factors, but then keeping in mind this is negative, so one of them will have to be negative. But 36 has a lot of factors. Okay, so now if I make one of them negative, which one's going to add to 0? Well, it would be negative 6 and positive 6 would multiply to negative 36 but add to 0. So it would be x and x, but then we're going to have negative 6 and positive 6. All right, let's try two more. So again, we're going to think about multiplies to negative 24, but adds to negative 5. Now 24 has a lot of factors too, so I'm just going to write down the positive factors, but then keeping in mind that it is negative 24, so I'm going to have to make one of them negative. So x, x. All right, so to get negative 5, I'm thinking it's going to be 3 and 8, but I want to make the 8 negative because I want negative 5. So 3 minus 8 or 3 plus negative 8 would give me negative 5. So this would be my final answer. All right, this last one's a little bit tough. So we have a positive 9 multiplies to positive 9 but adds to a negative 10. So 1 and 9 and 3 and 3. So I want to find the two factors that are going to add to negative 10. So remember, when we multiply to a positive, I could also have negative 1 and negative 9 as well as negative 3 and negative 3. So keep that in mind that multiplying to a positive number is always two positives or two negatives. So when looking at this list, if I want a negative 10, that means it had to be negative 1 and negative 9 because two negatives added together gives me a more negative number. So it'd be negative 1 and negative 9 would be my factors for number 6.